A massive solar flare hitting Earth could significantly impact modern technology and infrastructure. Here's what could happen. Disruption of communications. Radio blackouts. High-frequency radio waves can be absorbed by the ionosphere, leading to radio communication blackouts, especially affecting aviation and maritime operations. Satellite communications. Solar flares can disrupt signals between satellites and Earth, impacting GPS, satellite TV, and internet services. Power grid failures. Geomagnetic storms. Charged particles from a solar flare can induce electric currents in power lines and transformers, causing widespread power outages and damaging critical components of the power grid. Satellite damage. Electronics and sensors. Satellites can be damaged by intense radiation, affecting their electronics, sensors, and solar panels, leading to malfunctions or complete failure. Orbit changes. Increased atmospheric drag due to heating from solar radiation can alter satellite orbits, potentially leading to collisions or loss of satellites. Astronaut safety. Radiation exposure. Astronauts in space, particularly on the International Space Station (ISS) or on future missions beyond low Earth orbit, would be at risk of increased radiation exposure, which can have serious health effects. Auroras. Widespread auroras. Enhanced geomagnetic activity can lead to spectacular auroras, northern and southern lights visible much farther from the poles than usual, sometimes even at mid-latitudes. Navigation systems. GPS accuracy. Ionospheric disturbances can degrade the accuracy of GPS systems, affecting personal navigation devices and timing systems used by financial networks. Impact on aviation. Flight rerouting. Flights, especially over polar regions, may need to be rerouted to avoid communication blackouts and increased radiation levels, leading to longer travel times and higher fuel costs. Historical context. The most powerful geomagnetic storm on record, the Carrington Event of 1859, caused widespread disruptions even in a pre-technological society. Telegraph systems failed, and auroras were seen as far south as the Caribbean. If a similar event were to occur today, the consequences would be far more severe due to our reliance on technology, mitigation, and preparedness. Efforts to mitigate the impacts of a massive solar flare include monitoring and prediction. Space weather agencies, such as NASA and NOAA, continuously monitor solar activity to provide early warnings of potential solar storms. Infrastructure hardening. Power grids and satellites can be designed to better withstand geomagnetic storms. Emergency preparedness. Developing response plans to quickly restore services and infrastructure in the event of a solar storm. Understanding the potential impacts of a massive solar flare is crucial for preparing and protecting our modern technological society from such events.